So for this question, if we click on this button, they've given us the computer output. And so if we're going to complete the model, the number that's not next to a variable, that's like, it's like the y-intercept. And so that is the intercept, and you want to look at the coefficient there. So negative 16.8447 to the fourth decimal place. So there's no rounding needed because it's already there. There's our intercept. Attendance, the coefficient, the word coefficient means the number multiplying to the variable. So the number that needs to multiply to attendance is 0.0501. And then for number of shows, it's 0.0078. And price, the model came up with a coefficient of 0.2399. Okay, so part B is talking about interpreting the slope of specifically the attendance. So 0.0501, and that's low, but if you look at your results, it was statistically significant. So that means that we're with such a low p-value, we're really confident that attendance has something to do with receipts. Okay, so even though it's low, it is still having an impact. So we don't want, even though it has the slope is not very far off from zero, it's still statistically significant. So you don't want to choose either of those two options. The first option says independent of all the other variables, an increase in attendance will cause an increase in receipts. Now that's not necessarily true. With multiple linear regression, like what we're seeing in our discussion this week is that we're trying to predict calories based on some variables, and sugar is not statistically significant, but we all know that more sugar means more calories, right? So if you change the model a little bit, you can see sugar's significance change. So all the predictor variables, they can change based on the values of the other variables. So it means if you when you interpret a slope of a regression model, that means if we were to keep everything the same compared to a week with similar numbers, in other words, if the data was relatively the same, we'd expect an increase in attendance to increase receipts. And then in a week, which you paid attendance is 2,000, 30 for 55. Yeah, so for this one, you just have to plug in these values to calculate receipts. So you got your regression equation. So you'd plug in 200,000 in for attendance. You plug in 30 in for shows, and you'd plug in 55 in for ticket price. And those are all next to these slopes, so you'd multiply. And once you do all that multiplication, then you get your prediction plus the intercept. Don't forget about that. So 200,000. Oh, attendance is in thousands. Okay, sorry, I missed that. So we're not going to plug in 200,000. We're going to plug 200 because attendance is in thousands. I thought that number was having a huge effect. That was weird. So there's attendance, 200,000. We plug in 200 there. So 0.0078 times 30 rows. And then the price. I remember that, 0.23 times 55. Add that. Then subtract this intercept. 6.60. There we go. Is this likely a good prediction? Why do you think that? And you can see they're all asking us to look at r squared. So just like with simple linear regression, that r squared value can help us understand whether our model fits the data set we're given well. Now, a model can do a really good job of fitting a data set, but then perform poorly predicting outside the data set. So that's one thing to keep in mind. But since we don't have the original data set, we can't check to see whether it's predicting outside our interval of values. Okay, r squared is not low. It's really close to 1, which is as high as r squared can be. So yes, the high r squared value indicates that the model accounts for all of the variation, because r squared is telling you how much of the variation in the y variable is accounted for in the regression model.